Hello everyone, I am Naga Krishna Koneru. I am a technical architect with more than 11 years of experience. I worked on AWS services as a developer, administrator, and I'm working as an architect for AWS services, DevOps, DevSecOps. I also work on automations of all these services uh, for performance improvement and reducing the cost to the clients. Today, I'm going to discuss about the topic observability with open telemetry. So, this technical discussion will focus on observability principles and implementing open telemetry in our modern distributed systems. Let's get started. This is the agenda for today. First, we'll focus on understanding the observability by learning foundations and key concepts of observability. Then we'll deep dive with different types of telemetry data types and collection methods. Later, we'll focus on the architecture of open telemetry components and the implementation part, which covers open telemetry essentials as a third topic. And the fourth topic would be the data sources of OpenTelemetry and how can we integrate OpenTelemetry with other systems, other tools in our application. Let's get started with the deep dive. Before we start in details, let's focus on the foundations of observability. Um, we talk more about telemetry data over this discussion. So let's talk about what is telemetry data. Basically, it's like a collection and transmission of logs, events, and measurements from various systems, could be remote systems or distributed systems, to a central monitoring place for analysis. Once we collect this data would be used to locate the potential problems in the systems. So basically, DevOps focus on two metrics. Any organization looks into these two metrics. One is called MTTD, another is MTTR. So, mean time to detection. This is the time taken to identify the issue. And MTTR, like mean time to resolve, this is the time taken to resolve the issue after the issue is detected. So, identifying and resolving, these are the two metrics that are being measured by organizations. How quickly we are able to identify the issue and how quickly we are able to resolve the issue. Monitoring methods. So we will be collecting different types of telemetry data as we discussed in the previous slide, right? So what type of data we are going to collect? So the first one is RED method. The R represents rate, E represents errors, D represents duration. Rate. So the number of requests coming into the system per second, like requests per second or transactions per second. Errors. The number of failed transactions or requests in our application or a system. And the duration. So the response time, uh, maybe per request or per transaction from our system. And the second method is use method. In this, it focuses on utilization of the resources, like resource utilization, like how much of CPU used, how much disk is used. Saturation, like a queue length, for example, network packets or network requests are queuing up. Errors, so it could be hardware or software related errors. Say, for example, discrete errors, IO errors, these are all called as errors. Four golden signals. This method is recommended by Google in their site reliability documentation. So, four golden signals covers the first three uh, collections, like red plus saturation. So, the first topic is in this one is the latency, the processing time, the delay happening in the system, traffic, the request volume coming into the system, and errors, the failure rates in the application of the system, saturation, the system load that is happening within our operating system. So it could be an overall system or the application. And core web vitals. Okay, this is mainly focusing on the web UI or user interfaces or web pages or websites. The previous three methods what we focused on, they focus on the system, the infrastructure side, system side, and services side. But core web methods will focus on the web user interfaces, user experiences. The LCP, the largest contentful pane, it measures loading performance. FID, first input delay, measures responsiveness to user interactions. CLS, cumulative layout shift, measures visual stability during the load of that particular web page. Now let's talk about difference between monitoring and observability. Monitoring is like a reactive approach, tracks known issues, and it is best for small systems and monolithic systems, and it shows when the issue occurs. When it comes to observability, it's a proactive approach. It uncovers unknown unknowns, ideal for complex systems, and it shows where, when, and why that issue happened. So observability gives us more quicker way of identifying the issue and resolving the issue. And telemetry data type. So we talked about what is telemetry data, what we collect, and what type of data it is. So there are different types of telemetry data. One is metrics. It just explains about the quantitative measurements, like what is happening. It comes with numbers basically. Okay, logs. So it's like timestamped events that are decoded in the system. So what happened, when it happened. Okay, traces, like this is very important when we talk about observability. So it gives us end-to-end request journey within our application. So suppose I have 5 APIs. So the trace would help us to identify which API is performing slow or which API is actually broken. Okay, so it explains about where the bottleneck is. Profiles. So this will identify the resource level diagnostics, why my system is slow. Either it is because of CPU utilizations or maybe garbage collection is happening during that time. So this profiling will help us to identify the resource level diagnostics. This is this slide explains about pictorial way of your observability in the border systems. So here you see the application could be in public cloud and the on-prem, and we receive various telemetry data. So we call this MELT. M for metrics, E for events, L for logs, and T for traces. And these collected metrics will be pushed into observability solution, um, which we are going to look in our future slides. And different teams like developers, monitoring ops, security ops would be depending on this solution to identify any issues to resolve the problems. Okay, and this is just overall picture of how observability will be in our modern systems. So how can we collect these metrics? So there are two collection metrics actually: push method and scrape method. The push method is like applications will actively send the metrics to the collection endpoints via TCP or UDP protocols. In this picture, you see the backend service is sending the metric to StatsD. StatsD is in turn sending that particular metric to Graphite, which is a time series database. Scrape method is something where applications expose metrics for collectors. Say basically, applications won't push the data. Instead, the collection services, the data collectors would pull the data from the applications. Here in this example, Prometheus is actually scraping the metrics from this application. So basically, we can say it's actually pulling the data from the backend service. So when can we choose scrape? When can we choose push? So choose scrape when you're using Kubernetes or dynamic environments, and preferred centralized control of your all the log management, and when apps can expose HTTP endpoints. Okay, so basically, yeah, your apps has option to expose their endpoints, HTTP endpoints especially. Choose the scraping. Choose push when apps are short-lived and the real-time metrics are required for us, and apps run in restricted networks. So in scrape method, the apps that has HTTP endpoints exposure, yes, the scrape can be used. But when apps are running within the restricted networks and they have no option to expose their endpoints, so use the push method. Now we entered into introduction to OpenTelemetry. OpenTelemetry is a open source framework which standardizes generation, collection, and management of telemetry data. It's a CNCF project. Basically, it's incubated under Cloud Native Computing Foundation. So, same foundation is actually managing Kubernetes as well. The key benefits of OpenTelemetry are it's vendor neutral, and it supports cross languages and multiple languages, and it provides standardization of data collection, and it covers a lot of uh, metrics like logs, metrics, traces into one framework. And let's look at the OpenTelemetry architecture. So the architecture of OpenTelemetry has these main components: instrumentation libraries, receivers, collectors, processors, OTLT protocol, and exporters. Instrumentation libraries. So these will enhance applications to generate the telemetry data so that the applications can pump various metrics, logs, events to OpenTelemetry. And then the receivers are the ones which will collect the telemetry data from various sources. They could be applications as well. Collectors. They receive, process, and export the telemetry data. Processors. These processors will manipulate the data which was received and they transform before actually exporting them to backend services. OTLP protocol, it's a standardized protocol for transforming and transmitting the telemetry data. Exporters, whatever the data that has been manipulated and transformed by processors, the data would be exported to external observability backends. OpenTelemetry collector, this is a very important component of OpenTelemetry. It is a centralized executable that receives, processes, and exports telemetry data to multiple targets. Protocol support. It works with all the popular open source telemetry protocols. It acts as an intermediary between the applications and the backend analysis tools. And it reduces the resource consumption, centralizes the configurations, and it will improve the security. Now we'll talk about collector components, the components of the collector, the receivers, processors, and exporters. Receivers will be the entry points for telemetry data, and they accept various formats. Processors would be manipulating the received data by filtering or enriching or sampling the data and send it to the exporters. And the exporters would actually send the processed data back to the backend systems for analysis. And there are two more components that are part of optional components of collector. Connectors, they facilitate the connection or communication between the pipelines, and they transform um, different signal types, enable a multi-stage processing flows. Extensions, basically they enrich the component capabilities and they add performance analysis and they provide authentication services. This is a simple, a typical collector pipeline could be. So the receivers would be receiving the data from various sources and they send it to the processors, which the process in turn will transform the data and send it to the exporters. And the pipeline can have multiple receivers, multiple processors, and multiple exporters in a single pipeline. And so we are talking about OpenTelemetry would receive the telemetry data from various sources. So what are those data sources? Typical data sources of OpenTelemetry are application instrumentation. Yeah, basically apps using the SDKs. So they send the telemetry data, logs, events, metrics to uh, OpenTelemetry. So basically applications are one of the data sources. And the next ones could be service mesh. So the traffic metrics and traces from the service mesh tools like Istio are one of the data sources. The next one could be node level metrics. So data from kubelet. So this is from Kubernetes. The data coming from kubelet about the nodes and running pods are also the data sources. Kubernetes events, cluster events providing insights into system activities. This is also one of the data source. And the other sources for OpenTelemetry are logging daemons like FluentD and FluentBit, which will collect the data of the logs. So basically, they collect the logs from the containers within the Kubernetes cluster and they forward the logs to um, Open Telemetry. And various metrics coming from cloud providers like AWS and GCP, and liveliness and readiness data, which we call probes and health checks that are coming from Kubernetes clusters. And the container or runtime data, like the metrics about container states and resource usage of those containers, can also be sources for OpenTelemetry. And coming to the implementation approach for this OpenTelemetry, so there are two ways: auto instrumentation and manual instrumentation. So automatic instrumentation, basically it's called auto instrumentation. Like we can get started immediately for the visibility of the entire system, and it needs less development effort. Yes, it's a great start point for the teams to get started to know about orbit telemetry and implementation. And when it comes to manual instrumentation, so here it gives us more flexibility to customize the metrics, and it gives us the precise control, and we can focus on business specific insights and gives us flexibility as we discussed. So it gives us what we need and why we need and when we need. So the manual instrumentation, although it takes effort, it gives us the control on what we want to see. And this is the entire full observability stack. So start from the bottom, instrumentation, like adding the code, like SDKs to your application code. And then the collection starts, the data collection starts from OpenTelemetry. And then they have to be stored somewhere in Prometheus, Loki, Tempo, Mimit. These are different tools based upon the type of the telemetry data. We'll see in the next slides. And Grafana is a dashboard for visualization. So this is the simple pyramid which explains the entire observability stack for any application system. Yeah, typical observability stack components like the collector, like our OpenTelemetry collector. Tempo is like a tracing system, tracing collector. So basically, it is actually a distributed tracing system for a request. So it explains us how that particular request had the journey in our system. Loki, it's like a log aggregation platform for centralized log management. Prometheus, it's basically a storage. Okay, it's a time series database for metrics collection and storage. At the end, Grafana, So this is going to give a web UI for visualization, dashboards, and alerting. And in the next slide, so this slide actually is going to give you a overall picture. So this slide on the right side, it explains like, so we have VM1 and VM2, and the data is actually coming from two VMs. The fluent bit, if you see here, right, the fluent bit is running on both VMs. So basically, it's a log collector. It sends the logs to the uh, OpenTelemetry connector, and the OpenTelemetry connector would be actually um, collecting the logs coming from FluentD and other metrics coming from the VM2, like other metrics, for example, for node metrics, right? So node exporter would send different metrics. So those metrics would be sent to Mimir. Okay, and in the backend, the entire data would be hosted into Grafana database, into Grafana user interface. So here, the applications only interact with OpenTelemetry connector. So they don't know in the backend there is Loki, there is Mimi, there is Grafana. So applications simply interact with OpenTelemetry, but that's what they see. In the backend, OpenTelemetry collector knows, okay, the log should be sent to Loki and the metric should be sent to Mimi. So in this way, it reduces a lot of complexity for the applications to interact. So integration is very less here. So it would be very faster and easy to implement OpenTelemetry in the applications. That's all from my side. And thank you for your time and have a great day. Bye-bye.